Most of the information on this worksheet you should already know, but just in case, we'll go over it, and then I'm going to show you how to do proton, neutron, electron charts on the back. So starting with how to find the number of each. Protons, we use the atomic number, and protons are the same as the electrons. And neutrons, we take the mass number. Remember, that was the number after the dash, and we subtract the number of protons. The two subatomic particles that have most of the mass of the atom, in the notes we said that that's protons and neutrons, and that electrons are so light, they're negligible. We practically ignore them when we do the mass of each atom. We said that two particles are inside the nucleus, so that's protons and neutrons, and that electron clouds are outside, and we call that the electron cloud. Isotopes. So an isotope, or isotopes, are atoms of the same element with different numbers of neutrons. So you keep the same element, the protons stay the same, but the neutrons change. So same element, and but they're called isotopes of the same element. We know that carbon-12 and carbon-14 are isotopes because since they're both carbon, we know they have 6 protons. But then different mass number, that's this number after the dash, means different number of neutrons. So remember, our definition of isotopes was atoms of the same element. Since we've got N14 and C14, they are not the same element, and therefore can't be isotopes. In number 7, we have an atom with atomic number 29, and it has 32 neutrons. So we need to know the protons. We know the atomic number is the number of protons, so we got 29. Protons and electrons are equal, so we have 29. And neutrons, they tell us, is 32. Now we have silicon next, and it has a mass number of 27. And if we look on the periodic table at silicon, we will see that its atomic number is 14. And that also means we have 14 electrons. And our neutrons, we're going to take our mass number 27, subtract our protons from it. 27 minus 14 gives us 13 neutrons. And number 9, we have 16 neutrons and a mass number of 31. We're going to do the correct isotope notation. That is box 2 of your foldable, if that helps you to look over there. I actually don't know what element it is until I do a simple calculation. I need to find out how many protons I have. So I'm going to do 31 minus 16. That gives me 15. So that means this element is phosphorus. Its symbol is P. I'm going to put my mass number in the upper left-hand corner. That's a 31. Put my atomic number in the lower left. That's a 15. And then finally, one more, again, correct notation. I've got 9 neutrons and 10 protons. The element with atomic number 10 is neon, and that goes down here. And then to get my mass number, I just need to add my neutrons and my protons together. So 9 plus 10 gives me 19, and that goes in the upper left. I'm going to work through just a few of these with you, and you should catch on and be able to finish the rest of this chart no problem. In our first one, we have iron. The symbol for iron is Fe. And when I find Fe on the periodic table, I see its atomic number is 26. I also know a couple other numbers are going to be 26, the number of protons and the number of electrons. In this particular isotope of iron, we have 30 neutrons. So for my mass number, I'm going to add the protons and neutrons together. 26 plus 30 is 56. And when I write my isotope symbol, that's flap 2 of your foldable. If you need to refer to an example, you put the symbol and then the mass number in the corner, 56, and 26 at the bottom. And then you write out your name again, iron, a dash, and then the mass number after the dash, so 56. All right, we'll do silver 108 this time. I know that the symbol for silver is Ag, and I'm going to hunt around for that one on the periodic table until I find it, and I see that it's atomic number 47. I also have 47 protons and 47 electrons. Remember how the mass number is the number after the dash. So to get my neutrons, I'm going to get out my calculator for this. 108 minus 47, that gives me 61 neutrons. Isotope notation, I've got my symbol with my mass number at the top, 108. It's hard to see that 1 there, but it's there. And my atomic number, 47. All right, so let's just do, we'll do a couple more here. I like this one because it's kind of like we're starting the other way. We have the isotope notation first. We know that Au is gold. And we can write it gold dash 197. And you'll notice they didn't give us the atomic number. They really don't have to, because we could easily find it on the periodic table for ourselves. A lot of times we write it in just for convenience, but sometimes it's not shown that way. So I have found Au, and its atomic number is 79. And so I know that the next two columns are also 79, the protons and the electrons. That's a 7. And they didn't have to do the number of neutrons. We could have done that by doing 197 minus 79, but that's okay. That part's filled in. And then our mass number is 197. All right, I think we'll skip down here to numbers 25 and 26 because it can be a little bit confusing. We've got H. H, of course, is hydrogen. We can also write hydrogen dash 3. Symbol is H. This 3 is our mass number, so we'll put that right here. Hydrogen is the first element of the periodic table, so its atomic number is 1, its protons are 1, its electrons are 1. And then to get our neutrons, we need to do our mass number 3 minus our protons 1, so that is 2 neutrons. And the reason I wanted to do these, if you look down here, you see we have 1 electron, so you know that means 1 proton and atomic number. And you notice something similar, but not quite exactly the same. So since we have 1, we know we have hydrogen again. But if our mass number is 1 and we have 1 proton, we actually have 0 neutrons. Because remember, protons plus neutrons gives us our mass number. So we'd have to have 1 plus 0 to add up to our 1 mass number. So this hydrogen has a mass number of 1, an atomic number of 1, it's hydrogen 1. And I always have people ask me, how can we have these two forms of hydrogens? And that's when I remind them, these are examples of isotopes of hydrogen. Remember, it's same number of protons, so it's the same element, but the neutrons are different. And that's exactly what's different here, making these isotopes. You should be able to do the rest of these on your own. I should have an answer key in class if you need to check them.